Morning, everybody. Coach A here. I'm going to go ahead and teach you guys about segment addition postulate on my own because I don't really think there's going to be, I couldn't find any videos worthwhile to show you. So I'll do it myself. Well, started off, postulate just kind of means like, not quite a formula, more like a theory or an idea. So segment addition, we've already talked about line segments. I've got two right here on the little paper you're looking at. The way this is going to work is imagine I had like a meter stick, right? If I take this meter stick, let's say meter stick AV right here. Ooh, I can do this. Ooh, look at that. So let's say we take meter stick AV right here. Well, if I broke it up in a bunch of pieces, like, I don't know, 10 pieces, 2 pieces, doesn't matter. I broke it up into pieces. I didn't lose any of those pieces. If I put them all back together, then they're going to equal a meter, right? It's a meter stick. As long as you don't lose any of the pieces, they're always going to equal a meter when you put them all back together. That's what segment addition postulate is talking about. If you know what the whole thing equals, right, then you can take the pieces and add them up. When it comes to geometry, if you're missing something or there's a variable, you're always looking for an equal sign. You're always looking for somewhere in the picture, something is equal to something else. And that's how you're going to solve it. So if we look at this very first picture, here, I'll start here. So if we're looking at this very first picture, right? AV, line segment AV is 13. Well, AV is this whole thing. Let me go ahead and draw that. This whole thing is AV, and it equals 13. And then they're saying AT right here equals 7. And we're asked, what is the length of TV? This piece left. Well, I'm going to say this a lot, but pieces add up to the whole. The whole is 13, the whole thing. So we know that we've got 13. That's the whole thing. Well, if the pieces add up to 13, we know 13 equals 7 plus what we don't know. We'll go ahead and call this X. Hope you didn't get tired of seeing that because you'll see it a lot here. So the pieces are going to add up to the whole. Select that. There we go. So we've got 7 plus X. Well, I hope you remember some of your algebra because we're going to use a lot. A lot of concepts in geometry are very simple, very straightforward. I don't think this idea here, segment addition postulate, is difficult to really understand. But they're going to put a bunch of algebra into it to complicate things because that's, well, how they are. So speaking of algebra, we've got 7 plus X equals 13 right here. I want to get this X by itself because I want to know what X is. Well, I'm going to go ahead and do the opposite of addition. So we're going to minus 7 from both sides, because if you don't do it from both sides, you don't keep the equal sign. So we minus 7 from both sides. And of course, 13 minus 7 is 4 equals X. That is totally not 4. I'm a math teacher. Wow, that's 6. Oh, man. I'm recording this very early in the morning. Forgive me. All right. So, yeah, 6 equals X. There you go. Where is it? We can do this. Draw a different color. Yeah. Red's a little much. There we go. So it's just pieces add up to the whole. If you don't want to do the algebraic, you can just look at it. All right, the whole thing is 13. This piece is 7. Well, if I subtract 7 from the whole thing, I get what's left over, which is literally what we're doing here, provided you can do math, right? All right. So how are they going to complicate it? Well, they're going to complicate it with a bunch of variables. Looking over at this second one right here. Bunch of variables. So let's start working this through. We've got dA equals 2x minus 3, AB equals 5x minus 7, and DB equals 27. So the first thing you should always do when it comes to geometry is mark the picture so you know what you're looking at. If dA is 2x minus 3, then I want to see 2x minus 3 where dA is. And then AB is 5x minus 5. And then I will do my little funky drawing here. DB, the whole thing, right, is 27. Cool. So this one, unfortunately, can't be done just by looking at it. You're going to have to put this in an equation. You're going to have to work it through. I mean, this is the way it is. But all our pieces are here. So it should be easy. Pieces add up to the whole, which means this plus this equals the whole thing. And once you write that out, you have an equation. 2x minus 3 plus 5x minus 5 equals 27. Perfect. Right, well, let's do some math. First things first, I'm the realist. Second thing, you need to combine like terms. So ignore this 27 entirely and let's figure out what we can combine over here. I got 2x and 5x. Both of them are positive, which means we can slap them together to make a whole 7x. And the nice thing is these are both negative, right? Well, negatives can be essentially added up. They're going to stay negative though. So 5 plus 3 is going to give us 8. Equals 27. Perfect. That is a much prettier equation to deal with than this insanity. But we're going to keep on going. Opposite of subtraction is going to be addition. And I want to go ahead and start with that because remember, when you're dealing with x and you're trying to get things away from x, you always start from the outside and move inward. Since 7 is right next to the x, we're going to get rid of the 8 first. So plus 8 to both sides. These two cancel. That leaves us 7x on this side equals, I'm not going to mess this up, that is 35. Cool. Now, 7 is attached to the x through multiplication, so we need to divide it. We're going to divide everything, both sides, by 7. That's going to cancel these out. Oh, I'm already on it. I'm just going to leave x on one side. Get that lined up. And then 35 divided by 7 is 5. And boom. This, of course, is going to be representing some of the hardest questions you'll see. Absolutely the hardest questions you'll see on segment addition postulate. You're not really going to get much harder than this. So if this isn't too bad, well, we're doing good. And I think that's going to be it for this video. I'll have questions about segment addition postulate. We'll move on to the next thing very soon after I make a video for that as well. If you have any questions or whatever, feel free to message me. And yeah. Now, how do I stop this? Wait, no, seriously, how do I stop recording? Ah, there.